In this video, we're going to be looking at inverses, and specifically we're going to be looking at inverses of relations. So this is for the broad category. Now, if you can't remember what a relation is a set of points that can be graphed by a rule. So that's not a technical definition, that's what I like to think of a relation is. And then a function is a type of relation. So in this video, we're going to be looking at inverses, and this will be for the broad type. So not only functions, but other type of relations as well. And the reason is because with functions, when you're finding the inverse, there are some specific technicalities or unique attributes for it. So it's like when we looked at composite functions, fog, goth, etc., those type of ones, we had to restrict the domain some of the time. If you remember that the domain, if you have like the fog, then you have to make sure that when you put it in, that the range of gx is like a subset of the domain. So when we looked at that with regards to functions, we have to do a similar thing with regards to inverses, where we have to make sure that it's defined and we may have to restrict it. So in this video, we're just going to be looking at relations and we're not going to be focusing on functions. However, the method is exactly the same. So when I say that an inverse is a reflection in the line y equals x for a relation, that also means that it's an inverse of a function is a reflection in y equals x as well. And that's because, as I said here, a function is a type of relation. So beginning with the graph, this is the standard y equals e to the x, so exponential. And then we need to graph the inverse. So the inverse looks like this. You have the point here, which is 1, 0, and it goes up, and it goes like that. So there are multiple ways to think about the inverse. You can think about it as a reflection in the line y equals x, and this is a good one to initially start off with and to visualize, because if you draw the line here, then you can see that obviously it's not exactly the same, but it's supposed to be a reflection exactly in the line y equals x. And then just making note, with the original graph y is equal to e to the x, you have an asymptote along here, and that asymptote is when y is equal to 0. So that's because it approaches y is equal to 0. However, with the inverse, you have an asymptote along here when x is equal to 0. And that's a straight line either way. So it's either reflection in the line y equals x, and we can see that. You can also think about it as in every x point, or x and y point. So every x and y value is swapped. So that means whenever you have a point, let's say 2, 3, for the inverse, you swap these and it becomes 3, 2. So let's see this for this graph. You have 0, 1, and then that swaps to become 1, 0 for the inverse. You can go along this point here. We may have a point such as 1e, so that's approximate to 1, 2.7. And then along here, you'll see that around about 2.7, you have E1. So every point is swapped. So that means that's why you sort of get this shape here. When you get these points here, when you're getting x is a really negative number, so you're getting towards negative infinity, you get very close to 0. So this is sort of approaching. That's why it happens the other way around. When it approaches 0, it starts to approach negative infinity for the y value. You can also say with the asymptotes, originally we had y equals 0. If we're swapping every x and y value, that is now going to become x is equal to 0. And we can see that down here, we have x is equal to 0. We can see that in that asymptote. So you can see, well, visually, it's a bit easier to see a reflection in the line y equals x. However, the inverse is basically when you swap every x and y value, so all of them change. So the third way of doing it is by, if you're looking at equations. So if we're swapping every x and y value, then we can say that the inverse equation is just when you swap x and y, and then you have to rearrange. So initially here, as you can see here, we have y is equal to e to the x. So y is equal to e to the x. So if we want to find the inverse, we have to swap x and y. Then we get x is equal to e to the y. We take log e of both sides. We can bring the y down, log e is just 1. So you get y is equal to log e x. And we can see that this equation here, and the one we were talking about just before, is modeled by y is equal to log ex. And you know that x has to be greater than 0. And then you can see it has an asymptote down here, how it goes through the point at 1, 0, and it follows all of the following above. And that's why there are similarities between exponentials and logarithms, because they are inverses. So we'll look at one more example. So we have here the relation y is equal to x squared. So y is equal to x squared along here, and I've already drawn in the line y is equal to x. Then if we want to draw the inverse, well, firstly, if it goes through this blue point goes to the point 0, 0, then the inverse will go through the point 0, 0, because you can swap them around, it's still the same. It's all on the line y equals x, so it's reflecting that nothing changes. And then along here you have x values. So as x gets bigger, y gets gradually quicker. Now you can think about it the other way. So as x gets gradually bigger, y becomes a lot bigger. So it goes like this. There's a reflection in the y equals x line. And then you're going to have the point here, which is 1, 1. That's because when you swap 1 on 1, it's going to stay the same. And then it'll continue along here. So as you can see, if you turn your head, it looks the same as when you had here the blue line, and you've reflected in the line y equals x. Then we have to reflect this side. So that's when, let's take a point here, negative 1, 1. Swap those round, you're going to get 1, negative 1. So you get the point here, 1, negative 1. And it's going to have the shape along here. You can see that reflection, and it continues along. So you can think about it like either side or the whole thing, and then you're reflecting it, will look like this. If we wanted to find the equation, then we'll swap x and y. So we have y is equal to x squared. Then we swap, we get x is equal to y squared. That means y is equal to square root of x, but plus or minus, because it can be both values of x, as you see here. So this value here would be y is equal to positive x, y is equal to negative square root x. And you can see that these two equations model this function. So there are three ways of looking at it. So lastly, you can look at it using matrices. However, it's a lot less common. However, the matrix here is 0, 1, 1, 0. So that is a reflection in the line y equals x. So if you wanted to find the inverse of a particular point, let's say 3, negative 2. We multiply this out, we get 0 times 3 is 0, 1 times negative 2 is negative 2, then 1 times 3 is 3, 0 times negative 2 is 0, so the bottom one's going to be 3. And we can see how if this was relating to the x, and this is relating to the y, they have now been swapped. So as you can see here, the x and y values have been swapped. Then if you do it generally for an equation, so we have 0, 1, 1, 0, x, y, this will equal y, x. However, with matrices, it's less common. You normally change the equation, or if you're graphing it, use the other methods as well as finding the new equation.